Hello, everyone. My name is Vladislav Sozonyuk. I'm a senior advisor to the Director General of the Nuclear Energy Agency. Welcome to the webinar series on disruptive technologies for nuclear safety applications. This 4-webinar series is hosted by the Nuclear Energy Agency, the Korea Atomic Energy Research Institute, and the Korean Nuclear Society. This is the second event in series. The first webinar took place on the 16th of March and set the table for further discussion on safety versus innovations. We have discussed the NI 2050 broad initiative, its key findings and outcomes, and particularly those related to the safety, identified challenges for these possible applications for disruptive technologies. Today's webinar will provide an overview of emerging technologies in nuclear safety. The panelists will discuss the effects and possible implementation of the technologies, and they will address the regulatory viewpoint on safety innovations. And of course, we will share the examples and lessons learned from other industries. The series will continue in April with 2 more webinars dealing with specific topics related to nuclear safety, data-driven technologies, and cybersecurity enhancement. Let me point out that we will be recording each session and will post the records online in the near future. And now I'm very pleased to introduce you the distinguished speaker, William D. Magwood IV, who will make welcoming remarks and will chair this session. Mr. Magwood is the Director General of the Nuclear Energy Agency. Prior to this position, he was one of the commissioners in the US Nuclear Regulatory Commission, and before that, he was a director for nuclear energy within the US DOE. Mr. Magwood, the floor is yours.
Thank you very much, and welcome to all of you. It's a pleasure to have you join us today for this important discussion. As we discussed in the first of the series of webinars, we're very interested in exploring how disruptive technologies such as artificial intelligence, advanced manufacturing, big data, other digital technologies can be used in the nuclear sector. Obviously, the nuclear sector is not going to be, in most cases, the first use of these technologies. There are many other industries that have already gained great experience in the use of these advanced technologies, and we have a lot to learn from them. Of course, the big question for the nuclear sector is, how do we integrate these new technologies into nuclear facilities around the world? How do we do it safely? For that, today's discussion will first go over what are the advantages of these technologies, how can they lead to greater safety, but how do regulators look at these technologies, and how will regulators deal with these issues as these technologies come to the fore? So to explore that, we have a series of very distinguished speakers today, and after each one gives a presentation, we'll have a discussion to explore these issues in some depth. Until then, we look forward to your thoughts and questions as they come in over the course of this webinar, and we look forward to the conversation at the end. So with that, I'll hand the floor back to Vladislav.
Thank you very much, Mr. Magwood, for this welcoming. And now it's my pleasure to introduce the panel. For the discussion today, we have assembled the experts from both nuclear and non-nuclear sectors. These panelists will present their points of view on particular key issues, will share their experience dealing with innovations, and will discuss the perspective for disruptive technologies and the challenges for their possible applications in nuclear safety. These panelists are Mr. Mark Foy, from the UK Office of Nuclear Regulation, Mr. Jin-Ho Park from the KAERI, Mr. Alistair Nolan from the Organization for Economic Cooperation and Development, and Mr. Stephen Wood from the Digital Catapult. First, I would like to introduce Dr. Jin-Ho Park, a Senior Vice President for Nuclear Safety Research at Korea Atomic Energy Research Institute. He was formerly the Division Director for Nuclear Convergence Technology and he has over 30 years experience in structural safety analysis. Dr. Park, the floor is yours, please.
Thank you, Vladislav. Hello, everyone. I'm very happy to see you. Now, let me briefly present for the status of innovation of nuclear safety research in KAERI. Next slide, please. And next. Let me, this shows the KAERI's key organization charts. Our nuclear safety research group is one of the 5 major technology research groups. Next, please. Next page, please. Okay. Recently, our nuclear safety group has been rearranged for the innovative research and in preparation to the future R&Ds. As you see, we have 7 different research group divisions and 1 distinguished laboratory, which is an artificial intelligence laboratory. And each division also has various own laboratories. Our mission is to perform the comprehensive and innovative nuclear safety research from design to decommissioning. As you see here, this slide, we have made many achievements over the past decades. And we have a broad spectrum of nuclear safety research fields, from the traditional core technologies to modern digital ICT areas together. Together with the world's leading infrastructures, for example, Atlas and the severe accident facilities, something like that. Also, various kinds of nuclear safety research projects are currently ongoing. Next, please. Next slide, please. Oh yeah, current previous one, please. Yeah. Currently, we are planning 2 major research programs in Korea for next decade under the slogan of Goal 2030. One is this development of innovative technologies for enhancing the safety of operating nuclear power plants. Let me introduce briefly. Next one. Okay, next, please. Yeah, here for strengthening and improvement of the operating nuclear power plants, we have established 3 key research areas adopting innovative technologies, such as prediction for the minimization of fault chain accidents, and accident prevention technologies, and response for accident mitigation. Next, please. Yep. Firstly, in prediction area, 3 major projects are planned with 11 research subjects. And as you see the right side, main achievements of 6 main achievements. Here, you can see that a variety of Industry 4.0 technologies is going to be applied. Next one, please. In this prevention research area, both the internal and the external risks are considered from the lessons learned from Fukushima disaster. So we planned 4 major projects with 8 research subjects. Next, please. And this response research area, we are focusing on blocking the path from an accident to severe accident. So it has 3 major topics with 6 research subjects. Okay, next, please. Yeah, So now let me introduce another research program where our group is participating. That is the innovative small modular reactor. Next one, please. Yeah. Last year, all stakeholders of the nuclear sector in Korea joined the cooperation of the developing Korean innovative SMR. So now the top tier design requirements has been determined and the related activities are set out and ongoing for the R&D and design and verification and validation and for licensing. It is also aiming for deployment within 2030. Next one, please. Yeah, this shows the design goal and the specification of Korean ISMR and the required innovative technologies. So mainly we are aiming to apply the industry 4.0 technologies such as artificial intelligence, Internet of Things, digital twin, and so on. Okay, next one, please. Here, our nuclear safety research group will actively take part in these 4 R&D fields that mostly comprised of various innovative technologies. As you see here, four major areas we will actively participate. This project we are going to start around 2 years later. Yep. Next one, please. Okay. The time is limited, so I present very quickly. So please be understandable. Okay. In summary, at this presentation, just I briefly introduced the R&D activities. Next slide, please, Daniel. Yeah. Our nuclear safety research group is aiming the 2 major innovative R&D projects. As you can see here, one is development of innovative technologies for enhancing the operating nuclear power plant safety. Next one is we will take part in the development of ISMR, Korean version of ISMR, especially in the area of nuclear safety research. Okay, thank you. Thank you very much.
Thank you very much for your presentation, Dr. Park. As we can see, KAERI has a very impressive portfolio of safety research dealing with various innovations and new technologies. Could you please share your opinion? What are the key issues for the successful R&D and its validation and application?
Yeah, I think there could be a lot of points to discuss those issues. But the key issues are well described in the NI 2050 initiative report that I read. So presently, I want to suggest 2 additional points based on my experience. One is the cooperation between researcher and industry. For the successful application of new technology, role allocation between the two is highly recommended. For instance, after developing new technology throughout analysis and experiments, the researcher is trying to get more realistic data that are strongly needed for the verification and validation. In those cases, actually, it is very difficult to get the real data without the help of industry, who has sufficient data for the demonstration. I think because the industry deals with the real system. Thus, the participation of industry in the R&D project together is highly recommended, especially in the process of verification and validation. The other is the cooperation between researcher and regulator. By discussing the main concept and the advantage of a new technology, from the initial stage of planning, the researcher and the regulator can accurately estimate the suitable procedure and the expected time required to get licensing. Therefore, I think this kind of active cooperation will lead to successful results. Thank you.
Thank you very much, Dr. Park. These are very good points. To continue our discussion, I would like to invite another speaker, Mr. Alistair Nolan, a senior policy analyst from the OECD. Mr. Nolan leads various streams of the OECD substantive work on artificial intelligence and has also mentioned research and project on robotics and the impact of emerging technologies on production cycle. Thus, your point of view on what's going on other industries will be much appreciated. Mr. Nolan, the floor is yours.
Thank you very much. It's really an honor to be here. And next, please. So I'll just underscore the fact that I'm not an expert in the nuclear sector. My area of expertise has to do with artificial intelligence and with the application of emerging technologies in advanced manufacturing. This is something which we've covered quite comprehensively in a number of recent reports. This report on the left was widely quoted in the 2017 G7 action plan, for example, and this report on the right came out last year. Next, please. So I just mentioned that over 30 countries now have Industry 4.0 strategies. Next. And that artificial intelligence is now being applied in every stage of production, from product design through to industrial research, product use, supply chain integration, and so on. And I'll just say a couple of words about a few of these use cases. Next, please. Firstly, in product design, one example here is the integration of generative design software combined with 3D printing, which could really revolutionize product design. So an instance here is on the left. You see this is an aircraft bulwark partition. This is stronger and lighter than the partition it's replaced. This is where the cabin crew sit against. And this was designed not by a human designer, but with the help primarily of an artificial intelligence-based software called Dreamcatcher. This is included in the A320 aircraft and allowed Airbus to remove 450 kilos from the cabin. Next, please. We see in fabrication and assembly, defects in computer chips, for example, are often characterized by irregular shapes on a regular geometric pattern. And these irregularities attract a feature detector driven by artificial intelligence. Next, please. AI is also increasingly used to analyze the model of a machine or physical system represented by a digital twin, no matter where the actual physical machine is located. And using digital twins like this allows engineers to optimize production parameters in real time and to discover problems before these actually occur. Next, please. AI is also being used in industrial research. For instance, Boeing wanted to mass produce 3D printed metal parts for jets, but most of the useful metal alloys for 3D printing are not printable for a variety of reasons. So Boeing turned to an AI system run by a company called Citrine Informatics. And the AI trawled for data from decades of experiments, scanned 10 million possible recipes for improving alloy powder. The company even wrote a software so the AI could scan data from old printed reference books and handwritten notebooks. And so the process of discovery of the right alloy for 3D printing for the jets was compressed from a period of years down to a few days. Next, please. In aerospace, Airbus has deployed AI to identify patterns in production problems when building its A350 aircraft. This is the factory, I think, in Toulouse. So a worker might encounter a difficulty that has not been seen before, but the AI analyzes a mass of contextual information, information from other shifts in the production process and other stages in production process. And so the AI can immediately recommend how to solve a production problem, not always with the right solution, but it helps the worker. And so this has allowed the company to reduce the time lost through production disruptions by 1/3. Next, please. Now, very few companies bring together even many of these production processes. Perhaps the leading positive case is the Fanuc robot factory in Tsukuba in Japan, where Fanuc robots make other Fanuc robots. And the newly made robots undergo automatic testing and inspection, all of this being done by robots 24 hours a day, 7 days a week in the dark. Next, please. I'm going to talk about very briefly, three broad policy issues which are a challenge for all countries in deploying these technologies: diffusion, skills, and the digital ecosystem. Next, please. Next, please. The first point is that actually diffusion of these technologies is very limited so far. Even a mature digital technology such as cloud computing, and you see this graphic here, which shows the percentage of firms using cloud across different OECD countries. And you see big differences from Finland on the left, where 70% of large enterprises use cloud, right down to countries, even including Germany, although it's considered one of the progenitors, as it were, of Industry 4.0, actual use of cloud in German firms is very low. And in all almost all countries, we see a big difference between the extent of use in larger firms, that's the balloon at the top, and firms of other size classes. So this is even with a technology which should level the playing field in access to computation between small and large firms. The small firms lag. Next, please. But even in the large firms, this is the result of a survey conducted by an American NGO on 60 large manufacturers with turnover between $500 million to $10 billion a year. So these firms have no problem in accessing all the resources required to deploy AI. But just 3 of the 60 had mapped out where the AI opportunities lie within the company, and 56% had no plans to do so. Next, please. Many countries operate a whole portfolio of institutions to accelerate diffusion, and we need to know much more about the practices which work best. Next, please. Skills are a key issue. Next, please. So we know, this is from a variety of OECD exercises on data collection, we know that workers at every level of educational attainment, whether it's lower secondary, if you look at the horizontal line on the bottom, right through to those with masters or research degrees, at every level of educational attainment, when workers with those levels of attainment enter into a high digital environment, the need for training rises. Next, please. And AI skills are everywhere scarce. So this is the aggregate salaries of AI-related roles which were open, unfilled in these companies in 2017. This just is indicative that even for the largest companies that pay large salaries, many job openings remain unfilled due to the inadequate availability of skills. Next, please. We also don't know what the future occupations will be like precisely. An example is that after the introduction of the personal computer in the 1980s to the US workforce, more than 1,500 new job titles arose by 2014, everything from database manager to website designer. People didn't realize in the 1980s what was going to happen, what new occupations would be created. Next, please. Next, please. So the digital ecosystem, there's many aspects of an ecosystem which would be conducive to the deployment of these technologies. I won't go into all of them. I only have a couple of minutes left, but let me just mention a few. One has to do with access to fiber-based broadband. Fiber optic cable has a whole range of attributes which are important to facilitate the effective creation of an ecosystem for Industry 4.0. For example, very low latency, high data security, because if the cable is breached, the signal disappears automatically. And we see big differences across OECD countries in the extent of deployment of fiber-based broadband. Next, please. I mentioned previously the uneven rollout of, or uneven use of cloud computing. Cloud computing is ever more essential for Industry 4.0 because data is increasingly transmitted across firms, across establishments within the same firm, but across firm boundaries as well. So for example, BMW has the aim now of knowing in real time the status of every major item of production equipment in each company that is manufacturing key components in its supply chains, key components for its vehicles. So when you see underuse of cloud, under deployment of cloud, mistrust in cloud, this is something which could represent a hindrance for the use of these technologies. Next, please. Digital security. Well, it's hard actually to quantify the extent of this problem, although all anecdotal evidence suggests that it's becoming an ever more severe problem, even for industry. There was a case in Germany a couple of years back where hackers broke into a metallurgical factory and switched off the controls of the furnace, actually causing the furnace to burn down and to destroy the factory. And this digital security problem is going to become ever more severe in a world where we have, for instance, AI-driven malware, such as this infamous character deep locker malware, which identifies the target through facial or voice recognition. It will sit there waiting for you on your computer. Next, and my last slide. So the last slide has to do with data policies. So manufacturing creates huge volumes of data. People might be surprised to learn it actually creates more data than any other part of the economy. And here's a quote from Cisco: it would take a lifetime to manually analyze the data produced by a single sensor on a manufacturing assembly line. And this creates all sorts of policy questions around how we treat data, the effects of restricting cross-border data flows, for example, making them more expensive by obliging companies to process customer data locally. There's some evidence that doing so, if you take the example of BMW I just showed, where they have to integrate across suppliers which may be operating in many different countries, when you restrict those cross-border data flows, you increase firms' costs, you increase the complexity of doing business, and there's some evidence that this is affecting flows of foreign direct investment. Much more to say, but I'd like to give you just this taster. Thank you.
Thank you so much, Alistair. We very much appreciate this overview of global trends and industrial revolutions that is already here. I especially like this point on data security issues. So we are going to discuss this topic more in details during our last and next session. But let me ask you a question. What is your opinion? These emerging technologies that are already transforming whole sectors of global economy, what were the key factors that enabled them? Was it a pure economy, or was it a coordinated policy? What was the most important? What do you think?
Well, my first observation is that they are not really transforming the global economy at the moment. In fact, all OECD countries are experiencing a decline in the rate of growth of labor productivity, the output, the value added per hour worked, and the entire economics profession, as it were, is kind of exercising itself to try and come to an understanding, a consensus of why this is and why it's happening in a context where we are seeing huge technological opportunities, such as the ones I've just outlined. And I go back to my point about diffusion of these technologies being very slow and partial. And you know, if I wanted to draw a couple of insights that might have relevance to the nuclear sector there, I would just point out that these technologies create all sorts of dynamics and challenges for firms. Deploying AI in firms, it's not a plug and play technology. There's many other sort of intangible assets to go with it, including investments in hardware, for example, to integrate data silos in different parts of companies. And perhaps most important is you're never really aware a priori of what the return on the investment will be. It's not like many other types of digital technology, which are about standardizing and systematizing in ways where it's quite straightforward to see what the return on investment will be. You never know a priori if an AI project will fail. There are so many complexities involved. And so my last point would be that when you have a world where older managers of companies may be less familiar with the topic of the field of AI, which is changing every week, it's changing every few months, and new research breakthroughs. And it's young graduates who know most and would need to have the authority to act with more influence and maybe autonomy within firms. This also creates tensions within companies. And there's a sort of element of conservatism within incumbent firms which can hold back the deployment.
Thank you, Alistair. That's a very good point. To continue our discussion, I would like to invite Mr. Stephen Wood, a senior commercial manager for the Digital Catapult. He leads commercial operation, effectively connecting the Catapult to business and industry. So he will give us an example of a real application of disruptive technologies in many industrial sectors. Dear Stephen, the floor is yours.
Thank you, Vladislav. Hello, everybody. So I work for an organization with a slightly strange name, Digital Catapult. It was created for one purpose, and that was to increase the adoption of digital technology into industry. Next slide, please, Danielle. Okay, so we essentially drive early adoption of companies, and we try to make companies more competitive and productive as a result of the introduction of digital technology. And I can certainly sympathize with Alistair's observation about productivity around the world not increasing as this technology is rolled out, and I can possibly shed some light on that. And as Alistair identified, there are still many barriers to this technology actually having a major impact on productivity. And one of those barriers is that we are not short of examples of prototypes and what we call proof of concepts for this technology. What we are short of is actual scaled deployments of the technology, where we would expect it to make an impact. And there are a number of barriers getting in the way of that. And that's really what Digital Catapult is here to try and help industry overcome. So one of the things that we do is we help companies de-risk the innovation, and we bring in this concept of collaborative working, bringing in expert companies that can help them unlock the value of this technology. So next slide, Daniel, please. Now, we focus on 4 technologies. Now, I'll try and get through these very quickly. These to us are some of the major technologies that we consider to have the most, and will be more in the future. So what we call future networks is the Internet of Things, the generation of data from processes or from products, essentially from the environment, and the value of that data when it can be transferred to a central point, that it can be accessed and then analysed. The second area of technology is immersive technologies. Now, as more and more data is generated by industry, the challenge becomes how you put a human being into that very complex and confusing data environment and give them the tools to help them make sense of that data. And we're looking at immersive technologies like virtual reality, augmented reality, and what we call mixed reality as tools that will help industry actually achieve this goal. And a lot of it is around showing operators the data that they need at the time that they need it in a form that they can understand and then respond to. So that's a lot of the work we're doing there. The third technology area is artificial intelligence. And another point Alistair made was the fact that sensors on production lines generate so much data that it's beyond human capability to actually analyze and aggregate. So we're looking at how AI and machine learning can help industry actually get more and more value from this data. Now, traditionally, manufacturing uses about 1% of the data that it generates. So all of the value is really still within the data that they don't analyze and don't generate use from. So we're looking at how to get this technology much more embedded in industrial processes. And we have a number of accelerator programs that help do that. And then the last technology is around distributed systems, what is more commonly known or loosely known as blockchain. And we see this as one of the technologies which has probably the most disruptive impact on industry, such as nuclear. We are working with a number of industry sectors. We tend to gravitate towards the Industry 4.0 with aerospace and defence, and we're doing a lot of work with some of the heavy industries. So, for example, in the manufacture of glass, where you're looking at the way that sensors can be used on the actual glass furnaces to help the operators understand what's going on in their very hot environments within those furnaces, and then making better predictions of for example, future operation reliability and above all safety. So creating the kind of fail-safe environments to avoid possibly that meltdown scenario that was described by Alistair in a factory of that nature. We're also looking at helping supply chains and basically making supply chains more agile and more transparent. And that brings us into the nuclear sector. So next slide, please, Danielle. So we started working with the nuclear sector in about 2018. We were first approached because of something in the UK called the Nuclear Sector Deal, which was a funding agreement with the UK government, which had some rather stringent strings attached. And one of the strings was the obligation to reduce the cost of generating power from the nuclear sector by a large amount. I think it was up to 30% reduction. And that's a major step. So the nuclear industry in the UK then sought to, sorry about the background noise, just bear with me 1 second. Right, sorry about that, I'll continue. So yeah, the nuclear sector needed to do things differently, and it launched something called the Big Innovation Workshops, which I attended and introduced the whole concept of disruptive innovation, possibly for the first time, and then attended some of their follow-up workshops to help them understand how to embed this technology, this approach into their cultures. With mixed success, I have to say that there is a tendency in the nuclear sector naturally to be very conservative. And some of the examples that we show from other industries are anything but conservative. And that's what disruption really is all about. So it's how to challenge the industrial sector, sorry, the nuclear sector, and how to get them to think in a slightly different way. And that's still very much an ongoing process. More recently, we've been working with Sellafield. Now that the slide shows you some of the work we're doing around distributed ledger technologies. What we did was working with the UK nuclear industrial estate, represented initially by Sellafield. Workshopping what the challenges they have and whether they are suitable for distributed ledger technology to try and solve. And over the space of 2 workshops, we came up with 2 potential use cases. The first use case was around what we're calling the nuclear ledger. And what this will be a single source of truth around the location and condition of low-level nuclear waste in the UK. We want to create a ledger that will still be accurate and accessible now and in 100 years' time. The second use case was around the development of something we call the nuclear skills passport. Now, this is all about enabling workers when they arrive at a site to basically present verified evidence of their qualifications, their skills, safety certificates, and any recent experience that they have which would impact on their quality of work. Now, if they could do that in a verified way as they arrive on site, it would mean that they can start work immediately and avoiding the need to go through any induction or orientation sections that would possibly need to take place. So it allows the workforce to be much more mobile and therefore much more productive. And the technology that we use is something which is widely known as self-sovereign identity. It's the ability to reveal information about yourself under your control as a citizen without anybody seeing the actual data behind it. So it's a method of verifying who you are and the skills that you have. Now, where we are with both of these use cases is that we spent last year looking at defining them as challenges and then going out to roughly about 200 or so potential technology providers in the UK, all of which were either startups in the distributed ledger field or beginning to grow and what we call scale up. We had about 30 applications for each of those use cases. So 60 companies in total. And with Sellafield and its stakeholders, we narrowed it down to 8 for each use case, and then we got them to pitch. And then Sellafield could ask the right questions, understand some of the technologies and the capabilities of these companies. And then they made a decision. So we have 2 companies, 1 for each use case, now actually building blockchain solutions. And what will happen in the next few months is that we will actually start to add data to those blockchains, live data, real data, and we can then assess over a long period what the value and effect those blockchain solutions actually have. And around about September or October this year, we should have the answer to this hypothesis. Does this technology, this type of solution, actually solve or advance the problem? And that's really what we're trying to achieve. Now, on that way, we will learn a lot more about both the technology and the way that it will be applied and adopted in the industry. And at the end of the period, Sellafield will have a choice to make. It has an opportunity to walk away and say, thank you very much, that was really interesting. Or it has an opportunity to work with the startups and actually deploy and scale those solutions. Solutions that it can control. This is not the same as going to a major technology company and looking for an off-the-shelf product. This is about the industry helping to develop a product based on its specific and actual needs. So the last slide, please, Danielle. So thank you very much. I hope that was informative and I'm looking forward to questions.
Thank you very much, Stephen, for your presentation. It is quite informative and inspiring to see new technologies unlocking new business models, moving markets, and improving competitiveness. It is even more inspiring to see the data sharing technologies making its way into highly regulated sectors. To express a regulator's point of view on these innovation sectors, I would like to pass the floor to Mr. Mark Foy, the Chief Nuclear Inspector at the UK Office of Nuclear Regulation. He is a regulatory head of the organization. He has been leading the ONR for the last 10 years and has more than 30 years experience in all aspects of nuclear life cycle. Mr. Foy, your knowledge and experience is very welcome to this session. Please, the floor is yours.
Thank you very much, Vladislav. Hello, everyone. Next slide, please. So what do we mean by disruptive technologies? I think we heard from Steve just previously that it's about novel, innovative solutions to problems and challenges that the nuclear industry faces. Things or solutions that replace older processes or designs, established ways of doing things. Now, nuclear safety and security regulators across the world enabling and facilitating the use of disruptive technologies is perhaps a scenario that those in the nuclear industry may not necessarily recognize. But it's important to recognize that disruptive and innovative technologies can enhance safety and security of nuclear facilities. And it's a point that was made by other speakers previously. And it's an important fact that regulators across the world understand and want to see the industry and society benefiting from. We want to avoid regulation becoming a barrier to the adoption of innovation and disruptive technologies. And ONR and other fellow national nuclear regulators are actually willing to work with the industry to overcome such barriers, be they real or perceived. Just earlier this month, I participated in the US Nuclear Regulatory Commission's Regulatory Information Conference, the NRC RIC. And there were many regulators there, including the NRC and ONR, that highlighted the importance of innovation and disruptive technologies. And we also discussed the measures that each of us are taking to facilitate the adoption of safe and secure innovation within our respective countries. We also recognize the need to work together on global approaches as such technologies actually transcend national boundaries. It means working with industry and wider stakeholders to realize the benefits from technological innovation. Now, the benefits are numerous and again have been highlighted by others about improved productivity, reduced costs, improved competitiveness, particularly important in the energy market. But importantly, from my perspective as a regulator, it's about those enhanced standards of nuclear safety and security across the nuclear industry. Industry and regulators alike must not shy away from the opportunities presented by these new technologies just because they seem too difficult. We must ensure that we avoid fostering that culture of being risk averse. And that applies not just to the regulatory bodies, but to the industry itself. What I've got to emphasize is the nature of the hazards in the nuclear sector do dictate that change and the introduction of disruptive technologies must be subject to robust processes. And it's evident from the recent issues highlighted by the Boeing 737 MAX shortcomings that requirement's got to be met. What I'm advocating is that fit-for-purpose solutions require fit-for-purpose regulation, where regulators can remain flexible and agile, able to respond to that dynamic environment and the diverse range of technologies being considered for potential deployment. Next slide, please, Danielle. This includes rising to the challenges that such technologies present in terms of regulatory capability and capacity, our regulatory frameworks, and the standards against which we consider and assess them. But we do need to be proactive and prepared to overcome such challenges, including that lack of regulatory knowledge and understanding of a range of unfamiliar technologies within our sector, and that limited ability to understand the risks associated with some things that sometimes are immature, innovative, disruptive, but immature. So how do we ensure that we are well placed to undertake technical assessments of these technologies and subsequently be able to license their deployment and operation? It's only possible through effective horizon scanning, knowing what is out there, and the willingness to support the adoption of new, novel, disruptive solutions. It does require cooperation and collaboration with innovators, potentially extending across different industrial sectors, and working with fellow regulators of those different sectors, or indeed fellow national regulators across the globe. Can also work multilaterally through the IAEA and the NEA here today. By working together early in that design evolution and where it's being sought to be adopted in the industry, we can avoid any misconceptions of regulatory barriers that could potentially limit the design, and it would address face on the comments that we sometimes hear that we didn't do that because we didn't think the regulator would approve it. And that's without even asking for our view or our perspective. And I believe that we can achieve that contribution without us becoming part of the design process. What I'm highlighting is the importance of everyone working together, listening to and recognizing the different needs of each other, working to remove barriers and facilitate that successful adoption of disruptive technologies. Early engagement is important and benefits all parties. Innovators gain an understanding of the regulatory framework and regulatory expectations, with regulators providing input at much more meaningful and effective points. Also advising regulatory red lines that will allow optimum design development and prevent any nugatory work. It's about aiming to avoid undue regulatory burden where new technologies are being considered. In the UK, I believe the legal framework sets out a goal-setting approach that's based on that principle that we call a LARP, such that risks is as low as reasonably practicable. Because of the goal-setting regime, it provides a high degree of flexibility and a constructive environment for industry to achieve its ambitions, be that around disruptive technologies. It's technology neutral and doesn't prescribe design solutions, thereby enabling modernization and innovative and fit for purpose designs. Next slide, please, Danielle. The nuclear industry is perceived in many quarters as being overly conservative and not particularly modern thinking or innovative, relying on tried and tested solutions. Now, that wasn't the case when the industry was born in the 50s and 60s and Nautilus was launched in the US there. Currently pioneering for nuclear may not necessarily be pioneering for other sectors. Innovation for the next generation of nuclear plants will come in the main from implementation of proven technologies from other industries. Again, a point made by others this morning. The industry learning from other industrial sectors such as aviation, space, rail, oil and gas, and how they've used that technology will be important. How they've used things such as artificial intelligence in monitoring systems and equipment performance and health, then considering how it can be applied to a nuclear plant. A big challenge, but it can be overcome. Next slide, please. So what is ONR doing, the Office for Nuclear Regulation, as the UK's regulator? We adopt what we term an enabling approach, and we believe that extends to innovation. We've recently published our innovation guide here on the right. That's to inform industry and its supply chain that we are open to innovation and disruptive technologies. We're currently engaging to communicate this to both industry and its supply chain to get our message out there. We're also establishing an innovation cell of free-thinking, open-minded inspectors that will provide a safe space for innovators to approach us and work with us to discuss and test their new, novel and innovative ideas, and doing this without fear. We're also working with innovators considering disruptive technologies for the adoption in the nuclear sector in the UK. This includes industry and its supply chain, academia and research bodies and institutions, but also other regulators. Examples of this are what I've termed state of the art, and that's state of the art for nuclear. Computer-based safety and safety-related systems, smart equipment and devices, and complex programmable hardware, and also the security of computer-based systems that are important to safety. And then we've got other areas that I've termed future state of the art. And again, that's for the nuclear sector, about wireless technology and communications, nuclear robotics, autonomous systems, artificial intelligence and machine learning. In the UK, ONR, the regulator, is actually part of what we've got called the Robotics and Artificial Intelligence Nuclear Hub. That's university, industry and ONR looking at developing and demonstrating robotics and AI for use in various applications in the nuclear industry. Applications including remote handling, verification and autonomy, remote inspection and high-resolution imaging. A remote handling application is being developed using manipulators to replace human hands in glove boxes to handle radioactive material. That's achieving various levels of autonomy in terms of grasping, obstacle avoidance and fault detection. And that allows operating staff to remove from harm particularly important in alpha glove boxes. Disruptive technologies can bring high degrees of sophistication, but industry and regulators need to consider how this can be done to best effect. The nuclear solution does not always need to be unique. Another example of work is on next generation inspection approaches, using COTS or commercial off-the-shelf systems, operating remotely to inspect facilities. And we're looking at systems such as the Boston Dynamics Spot robot system that we're all familiar with. We're also working on guidelines for the industry, aiming to adopt autonomous systems. And we've held workshops with academia and industry on nuclear robotics safety cases and certifiable autonomous nuclear robotics. The benefits of ONR's involvement include us gaining awareness of the capabilities and limitations of the technology, understanding the barriers to nuclear industry adopting these new technologies well, and early identification of regulatory expectations. These are examples over and above the work that we're doing to support safe adoption of SMR and AMR technologies in the UK, stuff that was highlighted by Dr. Park earlier on. We're working with prospective vendors, government and other regulators, gaining an understanding of these technologies and providing clarity of the legal framework and regulatory expectations, as well as seeking to pursue opportunities for international regulatory cooperation on assessment and licensing approaches. I hope I've provided a flavour of our work that demonstrates ONR as a regulator is not intended to be and will not be a barrier to innovation, and that the appropriate adoption of disruptive technologies in the industry, be that for new build, decommissioning programmes, or existing plant and facilities. Next slide, please. So to close, I'd just highlight that ONR is open to the adoption of innovative and disruptive technologies in the industry, and we will remain flexible and agile, prepared and able to regulate such technologies. We're also seeking to avoid undue burden, but will still require safety and security standards to be met. And I think it's recognised that innovation and disruptive technologies can enhance nuclear safety and security, and all of us need to work together to ensure it's applied safely and successfully to the benefit of society. And I've just put a comment on the bottom there. Just because something is different, it doesn't actually mean it's wrong. Thank you.
Thank you so much, Mark, for your very informative presentation and very positive messages towards nuclear innovations. I think given these examples, we are set up for the short discussion on nuclear innovations and path forward and lessons learned. So I would like to invite all the panelists and would like to pass the floor to Mr. Magwood.
Thank you very much, Vladislav, and thank you all for your presentations and comments. Very, very thought-provoking. Let me start with, and particularly Alistair Nolan's comments about the three categories of barriers: the diffusion of technology, the skills, and the digital ecosystem, which I think I would call it the digital ecosystem and security, which he mentioned as well. All three of those, I think, and let me direct this to you, Mark, all three of those present significant challenges in the nuclear sector, because when you think of things like, for example, skills, the nuclear sector has a workforce that isn't necessarily a workforce that's prepared to deal with artificial intelligence. You know, we don't have those people either in the operating companies or in the regulatory organizations. Diffusion of technology, I think that's sort of self-evident with why that's a barrier. But also the ecosystem is very different. It's much more difficult to adapt an analog nuclear power plant to artificial intelligence than perhaps a new Airbus. So these really do, despite what you said about the regulators not wanting to be a barrier, the entire nuclear ecosystem presents something of a barrier. How would you react to that? And what do you think about these areas that Alistair pointed out?
I tend to agree with you, Bill. I think first off, there's got to be a willingness in the industry, and that's on all parties, to actually want to benefit from these types of disruptive technology, be it artificial intelligence or whatever. I think it is gaining momentum. And it's not just a willingness to gain from the benefits, it's a willingness to actually learn from other industrial sectors. And I think what we're starting to see now, we've got Stephen on in terms of the digital catapult, and he's already highlighted there some aspects of where the nuclear industry is looking to benefit from these new novel approaches. But I think there are still major inroads to be had. I think the skills and the workforce that currently sit within the nuclear sector as well need to develop and evolve. Even just within ONR, we're developing our own IT systems as we try to modernize, and that's about using data, not big data, but the data that we do have within the regulator, analyzing it better, presenting it better to inform our decision making. But the problem we have got is actually getting the skills into the organization that allow us to develop the systems necessary to start to interrogate and analyze and then present this data. It's been a real challenge for us. And I think that's the same for many other aspects of the industry, be it government or be it the licensees and duty holders themselves. And then again, the point that Stephen made there, the industry in the UK, and I suspect in other nations as well, is fragmented. It's not all state owned. They are all masters of their own destiny, owners of their own information, and some of it they guard as proprietary, and willingness to share that for the greater good is perhaps not there at this moment in time. So I think what I'm saying is there is some appetite for it to gain benefits, but there's a lot of work still to be done to actually consolidate that learning and be able to use and adopt some of the processes that have been outlined this morning.
And I think I certainly agree with that. And I'm afraid we lost Alistair. I know Alistair had another commitment he had to run off to, so I appreciate his very insightful comments, and hopefully we'll catch up with him at another time. So let me turn to Stephen to comment on what Mark just said, because what he said is absolutely correct. But there is the issue that something I believe you said, that the benefits of these technologies are not always immediately clear. That sometimes you have to take a little bit of a leap of faith to go down the path to see where it takes you, because you won't know. And I think it was Alistair that talked about how when PCs first came out in the 80s, no one knew that there'd be a job for a web designer, 15 years later. That is an issue in the nuclear sector, isn't it? Because, and you've looked at this, because the cost of change in the nuclear sector is sometimes quite significant. And if you don't know what the benefits are very clearly, how do you make that investment to go down the path when you're not sure that what's the pot at the end of the rainbow is worth the journey you've taken?
Yeah, it is the biggest challenge that industry faces. The way we approach it is to try and get them to understand what their long-term objectives are. Why is it they're actually looking at this technology in the first place, and what is it they hope to achieve? So it's really good to have this kind of long-term vision, but you can't just live off that. You need to start to experiment with the technology in a kind of a controlled way and generate successes, short-term and medium-term successes that will create a groundswell of support. But it will also help the organization to learn. We are not under any illusion that it's a quick fix. We've been working with the defense sector now for 6 years in the UK, and one or two of the major companies are seeing a cultural shift in the way that they view their products and the way that they view collaborating to actually develop new products and new solutions. So, for example, one company in particular, very, very strong product-orientated company, very, very strong technology, now thinking rather than being about products, but being about data-driven solutions and helping their clients, and the clients in this case are the military, but helping their clients to solve their problems, not just bring them a better product, a shinier box, if you like, but getting into the actual, lifeblood of what their clients need, and that's what we need all sectors to try and adopt. And on the skills question, I mean, this is always going to be a problem, or at least in the short and medium term. we encourage organizations to work with startups, because that provides them with an amazing resource, not just in terms of the availability of skills, but in having access to the best, most innovative ideas. And then blending that with their own in-house capabilities. So you don't rely on it totally, but you use it to help develop and understand, the things that you don't know as an organization. So there are a lot of things that we can help with.
So let me just follow up on that, because I wonder about the idea that you can take these small steps, and maybe there are some small discrete things that can be done in the nuclear sector. But one thing, and again, I'm sorry Alistair wasn't able to stay with us, because he highlighted the cloud as being part of the ecosystem that one would like to refer to. I'm not sure. I think the nuclear sector might be the very last industry on the planet to adopt cloud computing for lots of very good reasons. And so if you can't take full advantage of that type of ecosystem quickly, how do you make those small victories? How do you adopt these approaches where you take these steps?
I must admit that the whole issue of cloud is probably the most frustrating thing. And I have to disagree with you slightly there, Bill, that I think the defense industry is also going to be amongst the last, and bizarrely, the insurance industry. Well,
there's some good news.
I mean, there's two words that we need to explore. One is trust and one is resilience. And it's helping companies understand the meaning of those words in a kind of a solution sense. That, why should a cloud inherently be less secure than your own on-premises system? The only difference is that you can't see it. Technologically, it's not a lot different, except, their defenses are probably more modern than an on-prem defense. It's just a mindset that companies have. I mean, I've lost count of the number of times that companies have come and said, "Oh, we don't allow our employees to access the cloud," and which the answer is, you mean you don't know that they're accessing the cloud behind your back, because they are. Every company, people will access the cloud, and unfortunately, if you have a blanket policy, then the places they will go for the cloud are the less secure locations. So you are actually inviting problems by having that attitude. And I don't know how we're going to get over this. There are a couple of projects in the defense industry that are looking at secure cloud and verifiable secure clouds. We will get there, but I think it's going to be the biggest challenge.
Let me turn to Jinho Park, because a big part of KAERI's program is to try to, and I'll use a word that one of you used earlier, to de-risk. I think it was Stephen's word, to de-risk adopting these technologies. So KAERI can provide something of a framework for showing what some of these technologies can do, although it's not applying them on necessarily a commercial sector approach, but it is still demonstrating and then perhaps showing industry what the benefits are. Can you give us some examples of where you think you've been able to show the value of these technologies to the industry, to get them at least interested enough to take the next steps, perhaps in the future?
Microphone, Dr. Park.
Please turn the microphone.
Oh, yeah, I'm sorry. Your question is the next step of KAERI?
Yeah. Well, my question is, what is KAERI doing to show the nuclear sector that these technologies would have value enough to make an investment in the future?
Yeah. I think just before what I mentioned is the starting point for the next step, based on our experience just nuclear safety sector, we have experienced some promising technologies, but still that is still in ongoing. But we have not the outputs, just research and development stage. So for the disruptive technologies, we are still planning to go further. So additionally, what I want to suggest is in order for the disruptive technology to be successfully deployed in the market, I think the licensing is the key threshold to overcome both research and industry communities. So we KAERI also now the starting point using the disruptive technologies to nuclear safety sectors. So we think that it is highly recommended to the regulators then to participate in the working groups or subcommittees of the international standard organizations. Well, for example, I think ISO and ISE has already a nuclear technology committee, something like that, TC45 or in IEC TC45 and in ISO TC85, something like that. So even our R&D is very successful, and we can get the verification, validation, but the licensing is the last one. So the regulators should strongly participate at the early stage of the R&D. And so, yeah, thank you.
No, I was just going to say, I think I heard Mark Foy say that they were doing that at ONR. I'm going to give him a chance to react to what you just said. But let me ask you two questions from the audience very quickly, because I think you wanted to answer these. The first question is, can you talk a bit about because it's a lot of the work you discussed is very similar to work in other countries and other organizations. Very quickly, can you highlight where you're cooperating with others in this activity?
For the cooperation, the one is I think the one is the cooperation between the researcher and industry. For the successful application of the new technology, I'm sorry. You mean for the promote the innovative R&D for nuclear safety?
No, I'm sorry. It was one of the questions was, what, and I think it was particularly related to your SMR work and some of the other activities you specific research, that we were wondering if there was areas where you're cooperating with people outside of KAERI.
Yeah. So for the cooperation, just we are planning the domestically. Domestically, we are the last year we already joined the cooperation between Korean regulators and researchers and industry. But for the cooperation outside, the main host, the responsible institute is the KHMP now. So right now I can answer for that kind of cooperation outside the countries on the ISMR. For the thank you.
Right. Thank you. So Mark, let me give you a chance to react to some of Dr. Park's comments, because It seems like everyone thinks it falls back on the regulator. It's everyone points the finger.
Yeah.
And I'll note though, just that I'll try not to point at a particular company, but I remember when I was with the Nuclear Regulatory Commission, and everyone's wondering, why don't we do this? Why don't we use this technology? And the vendor and the industry said, well, we don't have a regulatory framework. It's all because the regulator hasn't developed a framework for us to do that, which I thought was completely ridiculous. Of course, I thought you could, if you really wanted to do this, you could do it, and we'd figure it out as a regulator. But that always comes back. The industry, others, governments usually say it's the regulator's fault. How do you change that perception? I know you said the right things, but people don't seem to be believing you.
It's about getting the message out there for a start, and actually demonstrating we are being constructive in our engagement with innovators and disruptive thinkers. And I think what I sensed a significant change over the last 2 or 3 years amongst regulators, amongst national regulators. I think there's a tacit recognition now that innovation is coming. The industry wants to use it. And as regulators, we have got to be prepared to regulate in that environment. And that means doing things differently as a regulator. So within ONR, I talked about the innovation cell. We're looking to establish that innovation cell that will allow innovators to engage with us without fear, and we will have inspectors that aren't hard and fast black and white regulators. They've got a degree of open-mindedness about them, are willing to listen, and a willingness to learn. And by doing that, you start to have a constructive dialogue about what are our red lines and what we can and can't give on. And I think you have to have that type of discussion. And it's not just ONR that's establishing this type of approach. Again, it came out of the RIC just the beginning of this month that others are thinking along these lines as well. But there's also the recognition that certain aspects of innovation and disruptive technology might need some adjustment to the existing regulatory framework. It doesn't mean a degradation of standards. It just means you might have to account for it in the framework that you currently have. And so we are mindful of that. We've not seen any particular instances at the moment where we've had to perhaps consider varying the framework in the UK. One aspect that we're considering as part of a particular reactor technology is a fusion technology in the UK. Now, that doesn't sit within ONR's purview at this moment in time, and there have been discussions as to whether we would be the appropriate regulator. If we were, we'd have to adjust the framework accordingly to ensure that it got the benefits of our regulatory approach, the depth and rigor, and effectively the kite mark. So we're looking to provide benefit to industry in that respect. So I think there's a recognition that frameworks might have to change. We're also aligning ourselves with the industry and the research it's doing around these technologies and how it's looking to bring them into the organizations. But we're also looking to collaborate internationally, not just doing things in the UK, looking to work with other national regulators such as CNSC, such as NRC and others globally to see what they are doing, to learn from them. They can learn from us, but also in that domestic context, there's that recognition. We talk about big data. The rail network in the UK is looking to use massive amounts of data to inform its maintenance, the performance, and how it can be improved and such like. There's got to be lessons there for the nuclear industry in terms of, and they've got access to the big data. And it goes back to the problem I highlighted before, that the data in the nuclear industry tends to be held within specific organizations. And so you don't get that pan-industry learning and data access.
Mark, can I just underpin that a little bit? And first of all, going back to the point regarding the willingness to innovate, I have to say the ONR were present at both workshops that I ran with Sellafield, yes. and they were the most forward-looking, supportive people in the room each time. We found them to be absolute champions, yes. To encourage the industry to go forward. The second point is about the rail data. There is a willingness to use railway data to basically improve the way that the network operates. We're working with them on that. They are very, very fortunate in that most of the data that they generate is by definition machine readable, which is a big advantage. Not the case in wider industry. But the use of AI is going to be problematic for the rail industry for a little while until we can create some method of basically what is known as explainable AI. In other words, putting a human into that loop so that there is always a verification and somebody to blame, if that's the right word. Sorry, sorry to interrupt.
But the other aspect we've got to get over there is that perception that the regulator won't support. You know, Steve highlighted there that we were forward thinking and we were open-minded. Most regulators are. And I think what I would appeal to the industry is ask us. Don't have a fixed mindset. Always approach and ask. If you don't ask, you don't get.
Steve, let me come back to something you said just a moment ago. You talked about AI and putting the human in the center. As I listened to your presentation and to Alice's presentation, the sort of the old concern about the people actually get in the way of these processes becomes more and more apparent because there's so much information. I think it was Alistair that pointed out, or maybe it was you, I can't remember which of you it was, who said that one sensor produces enough data in a manufacturing environment to take a lifetime to analyze if you did it by hand, which means that there's no way that humans can really know what's going on inside the data. There's going to be various generalizations that are made by the systems to enable humans to interface with it. The further you get down that road, don't you run into one of our audience members used the word ethics. I'm not sure I want to go down the ethics route, but they asked, does it present an ethical question after some point? I will ask, does it from a nuclear standpoint? I will ask a question not so much in terms of ethics, but in assuring safety, because if you want to have operators making decisions on safety, but the operators aren't actually making decisions anymore, it's actually an AI system. Where does that lead you? Does that take you down a very, very different path than where we are today?
Yes. I mean, these are all very valid concerns. And one of the reasons we're putting effort into this whole idea of immersive technologies, how you put a human into this very complex environment. Now, of course, you are not expecting the human to understand everything that happens, but we're looking to develop tools which gives them a overview, if you like, of how the system is operating. Essentially keeping their hand on the switch, but not interfering until there's a major anomaly, something that's not quite right. And then we expect the system to tell them what's not quite right and what it thinks is to be the causes. And then you have a human who can then make a value judgment as to whether to stop or change something. So this kind of control center or control tower approach is where we are putting a lot of our efforts, and so are our clients. And the two industries that are looking at it in the most advanced way is the rail industry and the defense industry, particularly around autonomous systems. So there is an ethics element to this, and the idea basically is that you can equip a human enough to verify that the machines made the right decision and give the reasons for that, and then correct any algorithm or whatever to make sure that these are human acceptable outcomes. Again, not going to be easy, but I think there is a pathway to it. And then the last point is, and this is one of the benefits of the distributed technologies, if you can record every transaction and verify the transaction using some kind of consensus mechanism, then you do have an audit trail that you can analyze and go back and see where things change and where possibly we think they may have gone wrong. That auditable outcome is something that I think is also very important. Nobody can go back and change the evidence and pretend that something has happened that hasn't happened, or vice versa. And
of course, that is after the fact.
Yeah. The thing is, if everything's recorded and immutable, now my academic colleagues tell me never to use the word immutable, but I can't think of another one for it. If every transaction is locked in place, as far as I'm concerned, that is evidence for posterity, and it can be analysed and found.
Thank you. We're essentially out of time, but Mark, I'm going to sort of close with you, because with all these digital technologies, the word that comes to mind for me is security. And that, of course, as you well know, had turned into a major issue over the last decade for the nuclear industry, and is one that I think people still struggle with to some degree. How do you see the reality of nuclear facilities and security as these new technologies come in? And I think I told you the story that when a vendor who was developing a new small modular reactor came to me when I was at the NRC and informed me that he planned that his system would use analog systems because he didn't want to deal with cybersecurity. That to me, that was a real message that the industry is very uncertain about what the future holds, and they should be uncertain. What do you think about this?
I think what you'll see if you look back over the last 10, 15 years ago is that there's been a gradual progression within the industry of adopting programmable devices, perhaps not for protection, but for some safety systems. If you'd come to us, 15, 20 years ago, that was a strict no. So things do change, perceptions and then reality about what is acceptable and what isn't acceptable. And I think one of the previous speakers was saying, you don't know, they're talking about job roles, how technology will move in the future. I think regulators need to keep an open mind. We regulate safety and security. So cybersecurity is very much at the forefront of our minds. But I think the reality of the situation is perhaps not in the UK, but I know other applications elsewhere. Some of these smaller modular reactors are intended to be put remotely in wilderness and such. How are they going to be operated? What's the intention there? Is there going to be a control room? They will be operated differently to how they're operated at the moment. And we put these planes in the sky, and they use modern processes and systems to control them, monitor them, report back to a central place. We need to look and learn and see what is an appropriate standard for the industry. So I'm not saying that you want to go the full hog of what's been adopted in other sectors, such as in aviation or indeed rail we talked about before. But there are things to be learned. Things do progress and move forward, and the nuclear industry needs to learn from them. And regulators need to be open-minded in relation to what are the proposals on the table, because they do provide, in many aspects, enhancements in safety and security. So it's not a carte blanche no. We will remain open-minded to those proposals and suggestions.
Well, I think that sounds like a good place to conclude the session today. So I will simply note first, thank you for all three of your comments. I think very, very insightful. And Stephen, I wish we had more time to explore the nuclear skills passport. I think that's a very important concept that could be applied in a lot of different areas in the nuclear sector. So it might be something I'd like to follow up with you on.
My pleasure.
But Vladislav, I think we're out of time, so I will hand the floor back to you.
Yes, thank you very much, Mr. Magut, and many thanks to the panelists for coming here and sharing your experience. Thank you, all the participants. We got a lot of questions through the chat, and I think most of them were answered on the course of the discussion, but we will pick these questions and maybe we will be able to address them during the next webinars. Thus, I'm inviting you to join the next two sessions that will be held in April. They will be dealing with more specific aspects of disruptive technology, data innovations, and the cybersecurity. So thank you very much, and thank you to our assistant and IT team for providing technical support during the webinar. Thank you.